Hi, this video is dedicated to creating successful Boolean differences in Blender. It is a two-part video. In the first part we will explore how Boolean cuts can fail. In the second part we will look at how to remedy these situations. Boolean differences are made between an object A and an object B. These two objects have to intersect each other. To begin, we will add a cube into the scene. Go to Add, then Mesh, then select Cube. Since Blender's 3D workspace is currently set to millimeters, we will scale the cube down by using the S key. In the Items window you will see that the scale of the cube is currently out of sync with the Blender units of measurement. To reset the scale, navigate to Objects, scroll down to Apply, and select All Transforms. The scale is now set to 1 in all slider bars. In Edit mode, notice how the cube has very few vertices. These are located in each corner. In order to change the mesh to mimic the mesh geometry of a typical 3D scan, we will remesh the cube. To do this, open a Properties window on the side. Select the spanner icon, then scroll down to remesh. For this demonstration we will use a voxel remesh size of 0.4 mm. Apply this. In Edit mode you will see how the cube has a new mesh geometry, which consists of quads. In order to restructure the mesh to look like a scan, we will triangulate the faces. Access the Face tab, then scroll down to Triangulate Faces. The mesh is now made up of many small triangles. We will first demonstrate a successful Boolean difference. To do this, we will duplicate the cube. Use Shift-D on your keyboard. We will scale the cube to a larger size. Let us repeat the process, so we have another cube. We'll place this one just below, and we'll resize this one as well. To make things easier we will briefly allocate colors to the cubes. The menu we are using is the Blenderfordental Model Designer menu. You can also access the color wheel through the world icon in the Properties window. To begin, we will move the smallest cube so it intersects with the blue cube. Essentially we have an object A and an object B, intersecting each other. The intersecting part can be seen by the outline within the blue cube. To create a Boolean difference between the white cube and the blue cube, do the following. With the white cube being selected and outlined in orange, select the Boolean modifier from the drop-down menu, then use the eyedropper to select the blue cube. Essentially we are cutting the white cube with the blue cube. Following this, apply the modifier. This will cut the cube. To double-check, we will move the white cube to the side. By inspecting the mesh in Edit mode, you can see that the mesh is still intact with a consistent mesh geometry. The corners have a couple of extra vertices as a result of the cut. It is always a good idea to inspect the face orientation of the mesh after a Boolean operation, to make sure no vertices or faces have turned inside out. Faces which are turned inside out are referred to as inverted normals. The outer surfaces of the mesh needs to be displayed in blue, while the inner surfaces of the mesh needs to be displayed in red. If you see any red areas, any future Boolean operations with this cube will fail. Inverted normals will create all kinds of issues, especially when 3D printing objects. To demonstrate a second Boolean operation, we will intersect this cube with the green cube below. Again, with the white cube being selected, we will create another Boolean difference. By using the dropper, we will select the green cube. Essentially we are cutting the white cube with the green cube. Let us apply the modifier. To double-check, we will move the cubes apart. In Edit mode, notice how the mesh geometry is still intact and consistent. The face orientation reveals no inverted normals. Even though we have performed two Boolean operations on the same cube, the cube is still free of any issues. Next, we will use Ctrl and the Z key to reverse all procedures so we can demonstrate a failed Boolean operation. Here we are back to where we started earlier on. The white cube intersects into the blue cube. This can be seen by the orange outline. With the white cube being selected, we will use the dropper in the Boolean modifier, so we can cut the white cube with the blue cube. We will apply this. As previously demonstrated, the cut has been made and each cube is its own individual entity. A surface-to-surface, or face-to-face contact exists between these two objects. While we have an object A and an object B, there is no intersection between the two objects. Remember, for a successful Boolean difference we need an object A and an object B which intersect each other. There is no clearance space between these two objects either, this means there is a face-to-face contact. If another Boolean cut is now made on top of the previous Boolean cut, the geometry of the mesh between the two contacting surfaces will be severely disrupted. This can happen if you press any Boolean cut menu button twice. To demonstrate this concept, we will select the eyedropper to cut the white cube with the blue cube for a second time. We will apply the modifier. Let us move the cubes apart to inspect the mesh. Immediately you will notice that there is an issue with the cube, even while we are still in object mode. We will inspect the integrity of the mesh in edit mode to see what effect a surface-to-surface cut has made. While zooming in, notice that some of the faces have turned inside out. These are inverted normals, and this is problematic when continuing to work with this cube. Remember, the blue color always needs to show the outside-facing surfaces, while the red color shows the inside-facing surfaces. Let us see what effect this has on a second cut. We will move the white cube into the green cube so they intersect each other. We will then apply the Boolean difference between the green cube and the white cube. When we move the cubes apart, immediately notice how there are mesh fragments dispersed within the environment. In edit mode, you will see that the underside of the cube is now open and the cube is no longer a solid object. This means the cube can no longer be used as an object in its current state. With this we will complete the first part of this tutorial. In the next video we will show how to remedy these issues. Thank you for watching this video.